do. What is happening the end of next week? The play. The play. And that play is something that I want to work around. I don't want to conflict with the play. So, you need to have the relearn packet done technically by next Wednesday. But I think it's very, very wise to have that relearn packet done this week if you're someone in the play. Okay? So, my advice to you would be to get to the library tonight. Make sure you watch the videos first. If you don't watch the videos first, I'm not going to help you. It's as simple as that. Watch the video for Section A, right? Section 1, whatever it is. Section A. Then when you're done with the video, do Section B, which will be right about Section A. On Section A, I answer the exact test questions. Section B, you do. Bring that to the library. Do it for every section that gave you a hard time. Bring it to the library. I'm going to go over it with you. Then you do Section C's. Once you have completed the Section C's, I take a look at those, and then you're ready for your retest. Okay? So, I think that there are, I think it's the time to do this. You really do need to step up and be a little bit better prepared, or a little bit more productive than you have been as a group lately. Also, listen, why do I give a series of 3 quizzes?
So you believe.
Yeah, so that you can grow. So that you can learn from your mistakes. Do you know how foolish it is to be given a series of 3 quizzes and not take advantage of that? In your other classes, when you get a quiz and you bomb a quiz, that's it, right? Yeah. Here you have a chance to rectify what's going wrong. To me, school is about character more than it's about intellect. And Vince Lombardi had a great saying. He used to say to his team, he said 2 things. He said, 1, given the fact that we're never going to be perfect, we're going to chase the heck out of perfection. Vince Lombardi, by the way, is the guy that the Super Bowl trophy is named after. It's called the Lombardi Trophy. He won the first 3 Super Bowls, I think, or whatever it was. He was the coach of the Green Bay Packers. And he died young, or he would have won a lot more.
What about the Jets?
He was
Jets
not
won the 3rd one.
All right, then he won the first 2 and the 4th. The Green Bay Packers were the dominant team early on. They were the team of the team. You're right, the Jets won the 3rd. So he probably won the 1st, 2nd, 4th, or 1st, 2nd, 5th, something like that. But he, dominant coach. The Green Bay Packers were the original great team in all of the NFL. He used to say, given the fact that we're never going to be perfect, we're going to chase the heck out of perfection. Then, he always used to also say, it does not matter how many times you get knocked down. It only matters how many times you get back up. What that means is, if you don't get back up, you've quit. You know, whatever. Pity party, feeling sorry for yourself, thinking I can't do this, etc. He wants the guys on his team who are not afraid to make a mistake. And then when they make a mistake, they step up and they say, okay, let me get this right. Let's do it again. And we'll do it again, and we'll do it again, and we'll do it again. We'll do it as many times as necessary until we get it right. Those were the guys he wanted on his team, and those are the guys he built championships with. He didn't build championships with guys who came in, did it once, and got it right away. He built championships with teams that took a while to learn how to get it right. Okay, so with that in mind, come tomorrow's quiz, I expect anybody who did not yet get 100 to get a 100 tomorrow. Now here's the beautiful thing where it all ties together. If you did not get a 100 on today's quiz, you just had an opportunity to talk to each other to get it straightened out. Also, with the relearn packet videos on the YouTube channel, all you need to do is go to the one, I believe it's section 304, and there is an example of how to do completing the square, and I talk you through it step by step by step with the one that was on the test. So if you do that section of the relearn packet tonight, not only do you get that done before you get your retest, but you'll have it done before tomorrow's quiz, and you can then do a really good job on tomorrow's quiz. All right, so everything you need to improve and to get where you need to be is there. Now it's just a question if you decide whether or not you decide to get back up. Okay, so now we're going to do two graphs, and we're going to do two graphs in completely different ways. I actually want to do graph D first, and then we'll go back and do graph A. I fear a lot of you turned graph A into graph D. Well, not the same exact graph, but the same technique. And I don't think that's what they were getting at when they asked you to do that particular question. So, I need a little bit of help reminding me of what graph D was.
X2.
X squared. Okay, so we have,
Minus 2x.
oh, hold on.
I can't say x.
Sometimes I think that, hold on.
Graph the wrong one.
Sometimes I think that if I don't use my pen in a given amount of time, that it just stops working. So, beautiful. What was D again?
X squared
Y equals x squared
minus 2x plus 1.
plus 1. Okay, good. So if I plug that into my graphing calculator, it gives me certain points to graph. Let me see. That would be plus 1, and if I put in 1, 0, so that's a good question, isn't it? How was I able to do that off the top of my head? I noticed something really cool about a quadratic pattern. I'll take a moment to digress and to show you this. Are you familiar with the law of entropy?
No.
The law of entropy is a scientific principle. It says that everything tends to a state of disorder. What it basically means is this. If you took a bucket full of marbles and you threw them in the air, they would land in a completely scattered fashion. They would not land in a line. They wouldn't land in a parabola. They wouldn't land in any other preformed shape. Now, I personally think a lot about, where life came from, how the universe is structured, and so on and so forth. And if you look in the universe, I think you see a tremendous amount of order. For example, assuming there was a Big Bang, if the Big Bang was truly random, would it produce, have you ever seen like how the planets go around the sun and stuff? Isn't that very structured, very ordered? And numbers within them have tremendous structure, tremendous order, even DNA inside of us. So I find the study of this structure and this order to be pretty cool, and I like to look at it. So there's this huge debate in mathematics. It's not a huge debate. Are numbers invented by man, or were numbers discovered? And the essence of the debate really comes down to, do you believe there's a creator or not? If you believe there's a creator, then the creator created the number system, as well as the planets and everything else. If you believe there's no creator, then you believe that numbers are random. And if you look at the number system, let's just take a quick look at the squares. What's 0 squared?
0.
0. What's 1 squared?
1.
What's 2 squared?
2.
4.
4.
What's 3 squared?
9.
What's 4 squared?
16.
5 squared?
Every other odd. I noticed that.
Right? 36, 49,
11.
64. Right. So if you look at the differences, I can look at this one. 1, 3, 5, 7, 9, 11, 13, 15. You create the odd numbers. Look, 1, 3, 5, 7, 9, 11, 13, 15. What, the next one would be 17. What do you think 64 plus 17 is?
81.
81. Next one will be 19. What's 81 plus 19? 100. The next one here is 121. Subtract it, you get 21. So I think it's pretty cool how it works out like that. And to me, I find that pattern, the fact that there are so many patterns in mathematics, to make me think and to want to investigate, well, what other patterns are going on out there, numerically speaking? What other things are happening? And it's pretty cool. There's a whole bunch of them. Like you've heard of the Pythagorean theorem, obviously, right? We have a thing called the Pythagorean triple, which is 3, 4, 5. and any multiples thereof, 6, 8, 10, 9, 12, 15. There's 8, 15, 17. There's 7, 24, 25. Oh, and I forgot another one. I forgot 5, 12, 13. And then the question is it possible to generate more? Is it always possible to generate a Pythagorean triple? All of those things. People who like math and the study of the logic thereof have spent centuries contemplating these questions. Another classic one, absolute classic question. Here's a line. Here's a point off that line. How many lines parallel to the first line exist through that?
Infinity.
None? Well, I
Three.
could think of one really easy. Right? Isn't that line parallel?
But that line was in.
No, you can draw. How many can you draw is what I meant to say.
Because
Oh.
the numbers keep on going
Infinity
after the
in the middle.
decimal. So if a line's at, if that line's 0 and the next line's 1.
Yeah, but
you
where's
can-
the next line?
Oh,
One line.
I don't know, wherever
Oh,
you
only
want.
one? Well, it really depends. Are we talking about a flat surface? Or are we talking about a globe? Like here's the equator. Here's a point off that line. Draw a point through that line that's parallel to this one.
Okay,
You can't.
yeah, you can.
Go ahead.
I mean, I'm a horrible drawer, but if this is a globe and it's round, it's going like that. So this is like the equator and this is like the top.
But that's not.
But if it's
not
parallel, it's
all.
equidistant in both sides.
Yeah, it's not.
You're suggesting that if this is distance x and this is distance y, that x is equal to y?
No.
Well,
It's not.
You're wrong.
oh yeah.
See, to go through that point, you actually end up being perpendicular. What we're really talking about is longitude and latitude, right? So questions like that make people think. And people who like mathematics, they get intrigued by questions like that. So it's pretty cool. If you want to look one up that's really pretty cool, got an interesting history to it, and just say to yourself, I just want to find out some interesting history. Look up something called Fermat's last theorem. Fermat's last theorem. Fermat was a brilliant mathematician, and someone got a hold of one of his notebooks, and he was doodling in the notebook, and he came up with a theorem. I don't remember exactly what it said, but it said something like x to the n and x to the n plus 1 and whatever. It had something to do with like Pythagorean triples. And he said that for x conditions, you'd always be able to create y. And he wrote proven in the margins of his book. Well, for hundreds of years, no one could prove it. And I believe about 10 years ago, someone proved it. So for hundreds and hundreds of years, someone tried to replicate the proof that Fermat made for his last theorem. So I'm sure if you go to like Wikipedia and you type in Fermat's last theorem, they'll give you all the history of it and everything that went into it. I mean, some of the most brilliant minds like Newton, you know, well, I don't know if Newton did it. Newton was before his time, but Einstein would have considered this question, didn't get it. Niels Bohr would have considered this question. Brilliant mathematicians have tried to do this and been unable to do it until like 8 or 10 years ago. Some guy actually came up with the theorem, or came up with a proof of the theorem. So it's pretty good stuff. Anyway, back to the parabola. We have a parabola drawn here, and now what we want to do is we want to emphasize certain key features of this particular parabola. And the first would be the zeros or the roots. The 0 or the root would be 1. The root itself or the 0, it's very important you understand, it's only 1. It is not, Lily, don't look away because I don't want you to mess this up on the test. It is not 1 comma 0. It's an excellent math teacher at Saxton named Mr. Anzalora. It's excellent. He made a bit of a mistake 3 years ago on the Regents exam. He was actually used to teaching higher level math. He went down to the middle school. He taught this course for the first time. And the question on the Regents was, what are the roots of a parabola that cross the x-axis in 2 places? And let's say one of them was here and one of them was over here. His kids all wrote 1 comma 0, whatever, 7 comma 0. And they were all wrong. The answers were just 1 and 7. Now, he would argue that this was an answer because it's where across the x-axis. But the roots are particularly defined as only the x value. If you put that a root or a 0 is 1 comma 0, you are wrong. Okay? The 0 is defined as, or the root is defined as, the value of x that makes the y 0. So to write 1, 0 is redundant. So you only write the 1. You only write the x-coordinate for roots and for zeros, okay? Next, what should we call it? Axis of symmetry. Line that runs right up the middle. What is that axis of symmetry?
1.
No, it is not
X
1.
equals 1.
X equals 1. Very good. If you write 1, you are wrong. It's x equals 1. The axis of symmetry is a vertical line. Vertical lines always begin x equals. Now, it happens to go through 1, and that's why x equals 1. Next, do you remember the algebraic formula that I gave you for finding the axis of symmetry? Not y equals. X equals.
Just kidding.
No. X equals negative b over 2a. That looks a little weird, but that's negative b over 2a. That's the third time now that I've written this formula on the board for you. We don't use it a lot, though. It's kind of one of those oddball things that every once in a while they slip onto the regions. Axis of symmetry is negative b over 2a. So if you look here, b is negative 2, a is 1. So the negative of negative 2 is 2, a is 1. So 2 times 1 is 2, so x equals 1. Notice, x equals 1 by calculation, x equals 1 by inspection. Either way, we come up with x is equal to 1. Okay? Is this a maximum or a minimum?
Minimum.
Over what interval is this increasing?
From 1 to infinity.
That's right, and it must be written almost like a point, 1 to infinity. Okay? Where is it decreasing?
From infinity to 1.
Negative infinity
Whoa, that's weird.
to 1. Yeah, all it means is this. Look, it's increasing as x keeps going this way. Infinity is like a destination. It's this place you get to that eventually, no matter how far out you go, the numbers are going to get so huge that you can't comprehend the numbers, and you can keep adding 1 to it. So we're just going to say that we get from 1, and you can keep going forever. That's all the infinity means. And on this side, you could have started at forever to the left. And the negative just means to the left. Okay, the negative side of the number line. Okay, I think we're good. Okay, so now, let's graph the next one. And when it comes to graphing the next one, you could, like I noticed, everybody understands, Nolan's a sharp kid. So he turns around and it says what here? F of x equals x minus 2 times, what was it, x plus 7?
Yeah.
And he says, oh, I got this. I'm just going to double distribute. And then I'm going to put it into the calculator. And I'm going to let the calculator do the graph.
I just put it in.
Well, that's not what they want you to do here. And while that's a good technique most of the time, I'm a little concerned because A, we've been working on this whole symmetry of a parabola idea, and B, there was a question on the regents, I can't remember which of the last 3 regents is, but it said something like, using the symmetry property of quadratic equations or of parabolas or graphs of quadratics, however they said it, graph the following. And what they expect you to do is to find the zeros first. So if I want to find the zeros, x minus 2 is 0, x plus 7 is 0, adding 2 to both sides, x is 2, subtracting 7 from both sides, x is negative 7. And then they want you to plot the zeros, which would be negative 7, 1, 2, 3, 4, 5, 6, 7, positive 2, 1, 2.
That's so cute.
Okay? Now, here's the thing. Isn't it true that with a parabola, we always have same on both sides symmetry?
Yeah.
And these sister points, if you will, are always the same distance from the middle. So based on those 2 points, you can find the axis of symmetry. What's in the middle between negative 7 and positive 2? What's the average of negative 7 and positive 2? Negative 2.5, right? Add them up, you get negative 5. Divide by 2, you get negative 2.5. So here's negative 2.5, and what that means is that this is my axis of symmetry. X equals negative 2.5. Now, isn't it true that the vertex is always found on the axis of symmetry? Does that make sense?
Yeah.
Right? Isn't the turning point actually on the axis of symmetry? Like if I just drew a parabola here, my axis of symmetry is right up the middle. Isn't the turning point or the vertex right on that axis of symmetry? So what I'm going to do is plug in the negative 2.5 into the 2x values. And that'll tell me the y, because the y is this thing times this thing. So x is negative 2.5. So f of x will equal negative 2.5 minus 2 times negative 2.5 plus 7. Now, negative 2.5 minus 2 is negative 4.5. And negative 2.5 plus 7 is positive 4.5. And if I multiply those, I get, I believe, negative 20.25.
Why?
Listen, watch, you ready? Let's say I have the line y equals 2x plus 1. If I say to you, what does y equal when x equals 3? What does y equal?
When x is 3,
Yeah,
f. Oh, 7.
right. You plug in the x, 2 times 3 plus 1, which is 7. Y equals 7. So we're saying, look, the vertex is on that axis of symmetry. So instead of putting 3 in for x, I put negative 2.5. Because it's on that. The x is going to be negative 2.5 for the vertex.
Oh.
And then I put it in here. And now I just do a little math. This minus this is this plus this is this times this is this. So what that means is, now, because it's going to be hard to fit on the graph, I'm going to go by 2's. So that means it's like right about here, at negative 20.25. And then I can set my graph up by doing this. And there's my graph. Okay? So what we're looking for here, when we use this technique, this is called factored form. When we use the factored form, the first step is to find the zeros. Lesson. Step 1, find the zeros. Step 2, use that to find the axis of symmetry. And step 3 is to plug the x value back in to compute the y value. That gives you the maximum or the minimum, depending upon the problem. And then you just do a quick sketch to connect the points. All right?
You're
Now,
not gonna take points off if when you make the sketch, they don't go through the y-axis or.
I think if you didn't go through the zeros or the roots, they'd probably ask to take points off. But other than that, I don't think they're gonna be too specific. Okay? Now, would I necessarily always do it that way? No. If they didn't say, like, the directions on that question said something like using the symmetry property of parabolas. So that means you had to use the fact that the distances are the same, namely that once you found the roots, or the zeros, these distances were the same. Because these distances were the same, that split me in half to get me the x is negative 2.5. That in turn, if I went and plugged it back in, as I did over here on the blue step, let me compute negative 20.25, and then I could do my quick sketch. But the directions specifically said, use the symmetry property of parabolas. If it didn't say that, and it just said sketch the graph, then I'd do exactly what Nolan did. I would do double distribute, plug it in the calculator, and let the calculator do the work for you. Okay? Having the calculator do the work for you is definitely easier. But I want you to be prepared in case they don't give you that option. So as you notice, of those 5 graphs, A, B, C, D, and E, on your homework, you'll notice there's another one like this. And when you do the other one like this, I expect you to do what I just did. Find the zeros, split them in half, plug in the x value to get the vertex, then come off to the side. Over what interval is this increasing?
Negative 2.5.
Negative 2.5 to infinity. Over what interval is it decreasing? Negative infinity to 2.5. Good. Maximum, minimum? Minimum. Axis of symmetry?
X equals negative.
X equals negative 2.5. I believe Anthony started to say negative 2.5 without the x equals. We want to make sure we go there, okay? Listen, this entire unit, I hope you notice we've slowed down. We do a little bit every day. We take our time, we digest it. So make sure tonight when you're doing your homework that you thoroughly get into how these graphs are done step by step. If you do it on a calculator, it's really easy, straightforward. But this splitting the difference technique, this idea of symmetry in a parabola, a little bit more challenging. Not particularly hard, but a little more challenging.